Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I'm your host, the Dabbling Doggo.
I dabble.
Last week, we learned how to create maps using the Vega Lite plotting package. We also learned how to layer those maps with some useful information. Today, we're going to return to the Makie plotting package to explore some of its interactive plotting capabilities. By the end of this tutorial, you'll be able to create dynamic plots that contain interactive sliders, buttons, and menus. Learning how to add interactivity to your plots will be another cool addition to your ever-expanding analytic toolkit. Let's set up our programming environment now so we can get to the fun stuff. Open VS Code and maximize the terminal panel. Start the REPL by holding down the Alt key and then hitting J, then O. Make a new directory called tutorial02by10 by using the make directory function. Change your present working directory to your new directory by using the change directory function. Enter the package REPL by hitting the closing bracket. Activate your new directory by typing in activate period and then hit enter. Add the following package and version. In today's tutorial, we will only be using the GLMakie package, which is the default backend for the Makie plotting package. GLMakie will load what it needs from the Makie package, so there's no need to add Makie separately. The reason we're not using GLMakie is because GLMakie only generates static plots, which are great for presentations, but doesn't allow for interactive plots. GLMakie will generate plots in a separate window, so it will not plot in the plotting panel in VS Code. Type in status to confirm that the correct package and version has been added. Exit the package REPL by hitting backspace. Minimize the REPL. Create a new file by going to File, New File. Save the file as tutorial02by10.jl by going to File, Save As. Be sure to save your file in your new directory. I'm going to be adding a header to my file, but there's no need for you to type this in. You can access the source code for this tutorial in my GitHub repository. The link is in the description below. So, I've been using VS Code for a few months now, and it's been mostly a positive experience. But there are several features that I find distracting, so I'm going to be turning them off. Turning them off is completely optional, so feel free to skip ahead using the timestamps in the description below. I'm going to turn off the linter, disable the hover options, disable the inline hints, and disable all of the IntelliSense options. The linter is intended to help find bugs in real time, but I find that this linter detects too many false positives, so it flags potential problems when there really aren't any. I think the hovers, the inline hints, and the IntelliSense options are all trying to be helpful, but I'm finding that all of this flashing information can be distracting. Go to File, Preferences, Settings. Go to Extensions, Julia. Uncheck everything that starts with Julia Lint under both User and Workspace. Go to Search Settings and search for Hover. Uncheck Editor Hover Enabled under both User and Workspace. Go to Search Settings and search for Inline Hints. Uncheck Editor Inline Hints Enabled under both User and Workspace. Go to Search Settings and search for IntelliSense. Uncheck everything that contains IntelliSense under both User and Workspace. Close the Settings tab. These days, static plots are no longer sufficient when it comes to analysis. In this age of self-service and DIY, people have come to expect some level of interactivity with data, whether it's for yourself as an analyst, or for your management team, or for the general public. This poses a challenge for programmers. In my Julia for Beginners tutorial series, I discuss how variables are really just memory locations that contain some value. Changing the value of one variable will not change the values of any other variables. Let's maximize the REPL and go through some examples. Take a look at the workspace panel and note that the initial values of x, y, and z are 1, 2, and 3 respectively. Now change the value of x. Notice in the workspace panel the value of x changed, but the value of z did not change. Now try changing the value of y. Same thing. Notice in the workspace panel the value of y changed, but the value of z did not change. Z is still showing the value of 3. Now enter z equals x plus y again. Now, the value of z changed to 30 in the workspace panel. If you want to interact with your data, you need to come up with some type of reactive environment so that when you make a change to an independent variable, all of the dependent variables will change at the same time. This is not how computers are designed to work, so you'll need to come up with some clever workaround. In order to create interactive plots, Makie has come up with its own clever workaround. Makie uses the concepts outlined in the Observables.jl package. The Observables.jl package allows you to create a new data type called an observable, which allows dependent entities to listen for any changes. The observable contains a value, and anytime the value changes, it sends out a signal so that any dependent entities that are listening can update their values as well. In Makie, you can set up an observable by using the node structure. Notice in the workspace panel, x and y are both listed as observables. If you twirl the arrow, you can see that they have a value of 1 and 2 respectively, and neither x nor y have any listeners. You can set up a listener by using the lift function. A listener is just another observable that is dependent on another observable. Makie includes a lift macro that is intuitive to use, so I'm going to use it here rather than using the actual lift function. Use the $ character to hook the independent observables x and y, and use the .broadcast syntax with your operators. Z is now a dependent observable that is a listener that will update automatically when changes are made to the independent observables x and y. In the workspace panel, twirl down the arrow for z and notice that it has a value of 3 with no listeners. If you look at x and y now, you'll see that they both have one listener each, which is our new observable z. This is essentially the same setup as our previous example, but watch what happens when you change the values for x and y. You can change the values stored in an observable by using the empty bracket syntax. Try changing the value of x. Look at the workspace panel and notice that the value of z has updated automatically to 12. Now try changing the value of y. Look at the workspace panel and notice that the value of z has updated automatically to 30. I can't explain how these observables are working under the hood. It's kind of like magic to me. Magic or not, this is basically how interactivity works in Makie. Makie provides widgets called sliders, buttons, and menus, which are basically observables that contain values. Moving a slider or clicking on a button or selecting a menu item will change those values. We can set up dependent observables to listen for those changes, so that our dependent observables can update automatically as the user interacts with those widgets. I realize that this concept may be too abstract to visualize, so let's take a look at an example. In our first example, we'll learn how to set up a slider. In this example, we're going to set up a line plot. The twist here is that we're also going to install a couple of sliders that will change the slope of that line and the y-intercept of that line, so we will be able to alter the line interactively. The first step is to initialize our scene by using the figure constructor. GLMakie does not generate SVG files, so we can only save images as a PNG file. Because of this, try to use the largest resolution that you can fit on your screen, because that's the size that GLMakie will save to disk. Remember, you can always shrink your PNG image for your presentations, but you cannot enlarge a PNG image without losing some image quality. You can see that the figure constructor generates a new blank window. Next, we need to set up our layout by using the axis constructor. I've provided a lot more attributes here than you probably need. I'm not expecting you to type this all in. I'm assuming you're just going to copy and paste my code as a starting point. I've provided all of these attributes so you can adjust the numbers to meet your needs without having to look them all up. You should now see a layout with a square grid. Let's add a couple of lines to darken the X and Y axis. Next, we're going to create some sliders to add to our plot. In order to add multiple sliders, we use the label slider grid bang function. There aren't that many lines, but there's a lot going on here, so let's go through the code. This label slider grid is like another box that we want to include in the overall scene. Fig identifies which scene we want to add it to. The array contains the labels that we want to use for our sliders, and the range sets the value range for the sliders. Ref is something that we haven't seen before. Ref is from Julia Bayes, and it has a couple of different uses. One of those uses is for broadcasting to treat the referenced values as a scalar. Here, we're using ref to create the same value range for each slider by using Makie's internal broadcasting. The formats is required because the values stored in the sliders are floating point numbers. So without rounding, they will show up with a lot of numbers behind the decimal point, which we don't want to see. The keyword arguments for label, slider, and value are all optional. I included them because the default settings for the sliders made the sliders look too small on my screen. Using these settings just make the sliders more readable. Okay, let's run this code to see what it looks like. Can you see it? GLMakie placed a couple of tiny little sliders in the lower left corner. This is obviously not usable, so let's make a few adjustments. Let's set the starting position for slope at 1 by using the setCloseTo bang function. Okay, so it's still not usable. Let's work on the actual layout itself. Okay, much better. I can't explain how Makie layout works, but in my experience, it's somewhat temperamental. The layout is designed to be dynamic, so the syntax to create the layouts is not always intuitive. This code created a new sub-layout, which was added to the bottom of our scene, and then it added the slider layout into that sub-layout. Bear in mind that Makie is still a developing package, so this is how it works today. There's no guarantee that this is how it will work 6 months from now. Try using the sliders. They definitely work. You can see the values changing on the right-hand side. Try changing the size of the display window. Notice that the size of everything changes dynamically. Okay, so the sliders are cool, but they don't do anything yet. They are just observables that contain values that change as we interact with the sliders. Now, we need to create a listener so that we can do something useful with these values. This binds the value of the slope slider to the variable called slope. Notice that the slope variable is of type observable. And this binds the value of the y-intercept slider to the variable called intercept. notice that the intercept variable is also of type observable. This just adds the range that we will use for the x values in our plot. This is our listener. Anytime we change the values of either the slope or the intercept by interacting with the sliders, the y value will update. Okay, now we just need to add our line plot. Because of its dynamic layout, GLMakie will sometimes automatically adjust the x and y axis values. If you want to reset them, you can use the xlimsbang and the ylimsbangs functions. Try moving the sliders now. Pretty cool, right? Now let's add some random data to our plot and try to adjust our line to fit them. Try to fit your line with the data. Fun, right? Unfortunately, you can't save this interactive model to disk, but you can take a static snapshot and save the image as a PNG file. The interactive plot window should disappear, and your PNG file should be in your project folder. So that was fun. Now, let's take a look at another interactive widget, the button. With sliders, we were listening for changes in value. With buttons, we're simply going to listen for a mouse click on the button. In this next example, our goal is to design an interactive plot that does something clever when we click on a button. Let's start by copying and pasting the figure and axis code from above, and then change the title. Like we did with sliders, let's create a grid for our buttons. This code just tells GLMakie to place our buttons below the plot. Notice that by default, GLMakie allocates the bottom half of the layout for this button grid. Don't worry, this will be adjusted once we create our buttons. So, we have some buttons now. Try clicking on them. They definitely work, but they're not doing anything at the moment. Plus, they're all squeezed into the bottom of the layout. Let's give them a little more breathing room. That's better. As with sliders, we created a sub-layout for our buttons to improve our layout. And now, let's set up 5 random datasets, and then set them up as observables, so that we can use our buttons to select which dataset we want to see. Let's also set up colors as an observable, so we can use our buttons to select the color as well. Finally, let's set up marker size as an observable, so we can use our buttons to select the marker size as well. Now, let's generate a scatter plot to see what it looks like. Crop the window until you find a view that you like. Reset the axis limit if necessary. Try clicking on the buttons. Nothing, right? That's because we haven't told them to do anything yet. Let's set up some instructions for our buttons. The on, do, end syntax is from Julia Bayes. This syntax is a way of setting up an anonymous function. Within this syntax, you can add as many button click instructions as you like. For each button, this code is telling GLMakie to select a different dataset, a different color, and a different marker size. Try clicking on the buttons now. They should all display different datasets, colors, and marker sizes. Pretty wild, right? Go ahead and save this plot. So, those buttons were cool, but what if we wanted to select the data, color, and marker size separately so that we can mix and match? For example, what if we wanted dataset number 3 in cyan with a marker size of 12? We can do that with menus, so let's take a look at doing that. Let's start by copying and pasting the figures and axes code from above, and then change the title. Let's also change the background color to black. You should now see just a black square. We're going to reuse the random datasets from the buttons tutorial, but let's set up some more options for colors and marker sizes. Now, let's create our menus for data, color, and marker size. Simply use the menu constructor and add the menu options as a vector. Now that we have our menus, we need to create a menu grid. This time, we're going to place our widgets to the right of our plot. We can create menu labels by using the label constructor. Take a look at the plot. You should see your menus on the right-hand side. Try clicking on the drop-down boxes. We haven't told it to do anything yet, so they're just widgets at the moment. Let's initialize some plotting variables and then generate a scatter plot. Reset the axes if necessary. Okay, now that we have our menu and our initial plot, let's set up some instructions for our menu options. Setting up instructions for the menu option is similar to the buttons instructions. Rather than listening for clicks, now we're listening for selection. Try selecting different datasets. Now, try selecting different colors along with the different datasets. Finally, try mixing and matching all of the different menu options. Crop your plot until you find a layout that you like. Then, save your plot. Be sure to hit Ctrl S to save your .jl file. Well, that's it. Congratulations if you made it this far. Today, we used GLMakie to create dynamic plots that contain interactive sliders, buttons, and menus. Not only are these widgets fun to play with, they are also a valuable tool to help us analyze our data. Rather than having to generate multiple plots with minor modifications, we can simply add an interactive widget to go through different scenarios using just one interactive plot. Having these tools available also allow us to communicate our data with a more general audience, who may gain a better appreciation for the data by being allowed to interact with it. If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more wholesome Julia tutorials, please be sure to subscribe and hit that bell. New tutorials are posted on Sundays/Mondays. If you have any questions, please post them in the comments below. Please feel free to share these videos, since these tutorials are getting rave reviews. Just listen to what the professional reviewers are saying.
Perfect.